Because apparently I put the wrong pin in. Oh my God, computer, would you please work? Okay, I don't know what you're doing. All right. Alrighty. Okay, so you know what the vertex is of this one? 1. So it's 1, 3. So that you're gonna grab the click to enlarge graph thing, graph tool, and then you're gonna pick the. Why can't I write on your screen? That is so crazy to me that I can't figure out how to write on y'all's screen. Can you see my mouse? No. God. You click that one. I think it's kind of selected already.
Yeah, I did click it already.
Okay. And then you go over to 1 and then up 3 and place a dot. And then what is the y-intercept? So the y-intercept would be you plug 0 in for x. So you would get 1 plus, so it would be 4. So 0, 4 is where you plot the other point. Yep. Did you catch how I got that? Okay. And then check answer. And then the axis of symmetry is always the x value of the vertex. So it's going to be x equals 1. It cuts the parabola in half. If I could draw on the screen, I would. I don't know what that's about. That I can't annotate. The domain is all real numbers, so that is negative infinity to infinity. Has everybody started the homework?
Is the range negative infinity to infinity too?
No, the range starts where the parabola starts. So that would be 3. I think it's bracket. I think it's bracket. I think. It'll tell us if we're wrong.
Like that bracket?
Yep, no, that's a brace. The bracket is I don't know. I don't see it. I do not see it. It is. Do you have why don't you have it on your keyboard? Oh, it's right under the 0.
30, you said?
Yeah. 3 to infinity. 3 comma infinity.
And then
parentheses.
wow.
All right. Now, this one is a little bit different because there's a 3 in front, but the vertex is still going to be 1 comma negative 1.
Oh.
Actually, it's not that different because you still have to plug in 0 for x to get the y-intercept.
That it?
Is that 1 comma negative 1?
Yeah.
Over 1, down 1?
Yeah.
It looks like it's on 0.
Huh. 0's up here.
Oh, that really looks strange to me. Okay. And then you plug in 0 for, no, you can't. The other point is the y-intercept. You got to get the y-intercept from, plugging 0 in. So you get, what do you get? 1 plus 1 is 0. So it opens up, my dear. You have it upside down. So
what?
just clear it out, delete it and clear it out or whatever. Just start over. All right, so you go to, what was it? 1, 1. Mm-hmm. And then up to 0, because when you plug X in for, I'm sorry, when you plug 0 in for X, let's see, I need something, food or something. But when you plug 0 in for X, you get -1 squared, which is 1. And then the 1 on the outside is -1. So 1 minus 1 is 0. So it's 0, 0. Should be 0. I'm sorry, 0 for the y-intercept.
Like that.
Yeah. Do you understand all of the stuff
That's
I said?
also.
Okay. Okay, why is it wrong? It says substitute 0 in, right?
Find substitute 0 for X and simplify to find F of 0.
Yeah. Oh, it's the 3. Okay, so it's 3 times 1, so it's 0, 2. Yep. Yep, it was 0, 2, because 3 minus 1 is 2. That's what I get for doing it in my head.
Okay, thank you, Jesus. So that would be -1. I mean 1.
Yep, it'd be, does it say type an equation in? It says type an equation in, so you gotta type X equals 1. Mhm. Same thing. All real numbers, because what it means is that all X's are allowed. So any X you can plug in there, you're gonna get a value out. There's no restriction on the domain.
Right.
So what's the lowest number there?
-1.
Mm-hmm. So essentially it's the K. It's the K of the vertex. And then it's rising up towards, goes on forever. Yeah. Yep. Alrighty. Determine without graphing whether the function has a minimum value, a maximum. Okay, so if the A is negative, is that a minimum or a maximum? It's flipped upside down, right? Because there's a negative in front. So it has a maximum.
Oh, okay.
It's okay. It is all right. Okay, so click view an example so that you know what to do. Does anybody have YouTube TV? No. Yeah. Yeah. Well, while I was watching the news last night, it just disappeared. The whole entire ABC disappeared. So they're fighting over, like, they're trying to negotiate and raise prices on consumers. I was like, if you billionaires don't stop raising, don't raise another price. How much money do you need?
So does this mean you put 18 over 2 times -3?
Yep.
And that's
It's negative
18 over -6.
Well, hold on. It's negative b over 2a. So there's a negative already. So then so
-8.
Is that right? So -18 divided by -6,
Yes.
which is 3. So, and
Wait, no.
yeah, the X is going to be 3. And then you plug X into the function.
To get the minimum or maximum.
Yep, to get the Y value, because that's what really it is. It's the Y value. The other one.
Somebody gotta do it for you.
Can somebody
Plug 3 into that.
let me see if I can do it real quick. -3 times 3 squared plus 18 times 3. Oh my God, it went into the exponent. Like, why would you do that? Plus 18 times 3 plus minus 9. It says 18.
18 is the answer.
Provided I did it all correct.
Oh yeah.
Okay, let's take a pause. Is everybody caught up? Is everybody following us? Are you ahead of us? Where are you at? So you're slightly ahead of us.
It's negative b over 2a. Now he's 1 behind us.
Oh. Okay.
So that means we put negative 18 over 2 times negative 30. That gave us negative 18 over negative 6. That gave us 30. So that means that the maximum occurs at x equals 3. And then you got to plus 3 into the equation to get the minimum or maximum. And we did that, we got 18. Because A is negative 3, B is 18, and C is negative 9.
You're a good explainer. You're welcome. I would be over there, except I just wish I could just draw. Like, I could scribble a little bit on the screen, but I don't know why it won't let me annotate. There's supposed to be an annotation button.
Stand up there and do it all yourself.
Oh yeah, there's a desk over there. And there's a plug over there. There's plugs, there's a power strip and a extension cord over there. Great idea. You're awesome.
Oh.
Where is Serenity supposed to be? Okay, I can't call there. Y'all don't answer the phone. Who's next? Here. All of you should be writing at least something, even if you're the IXL doing the IXLs. You should. The domain? Yeah. Okay, so let me put your example up there again. And then go to the domain. Okay. Actually, almost all functions are going to be all real numbers except for the square root function and the rational function. So the parent function, I'm going to delete this. The parent function, y equals, or yard and college algebra. So I'm going to use f of x. F of x equals the square root of x, and f of x equals 1 over x. They both have restrictions. So those will not be all real numbers. Okay? Because this cannot be 0 and this cannot be negative. So you can't put any function in there. Now, when you transform, it'll trick you, because when you transform functions, I can have f of x be equal to negative square root of x. And if I start adding stuff to it and blah, 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 put numbers in front of it, you can do that. It's just the number inside the grouping symbol cannot be negative. It's not allowed. Okay? So there's always going to be a restriction with these two. There's other ones that have restrictions, but those are the main ones starting out. So anytime you see a straight line and it goes on forever, if you see a parabola and it keeps growing forever, if you see a cubic function, so you know, I hate the color red, by the way, too. I hate that it defaults to red. Can I fix that? But the f of x being equal to x cubed, it looks something like I don't know, something like that. It's a polynomial, but it has arrows on it. Yeah. Leave keeps touching. But that's the x cubed function. And we don't usually go past x cubed in terms of algebra, like doing algebraic stuff. So yeah. All right. So this gives you a little heads up. Okay. Okay. And I'm definitely using this to make a video. That up. I'm trying to figure out how I screwed that up. Because the vertex. Oh. You plugged 3 back in. Did you say that? No, you didn't say that. So when you get the X value, yeah, remember we plugged it in. We had it already. I know. I told you. Sometimes I'm just. You did. I thought you did. You did example while I type here. Education. Oh, finish. Why did she? It's like, looks like it wants you to do it separately. So now determine whether the graph crosses or touches the x-axis and turns around at each x-intercept. If r is 0 or even multiplicity, the graph touches the x-axis. Okay, so the rule is, I think if it's even, what did it say here? If r is 0 or even, the graph touches the x-axis. If r is 0 or odd multiplicity, the graph crosses the x-axis. Now, you can also use Desmos to check to make sure you know if it crosses or touches. So, again, that's why I say always have your notebook so that you can write down your function, whatever function you have. But the zeros are what? Do you know the zeros? So let me show you a little trick with your calculator. Insert calculator. Okay. So to find the zeros, if you go to menu, algebra, zeros, and I don't use this that much, so hopefully I do this right. What is yours? X minus 7? I'm just going to do the first one. I'm going to do them separate. Okay. And then, so one is 7, and then the other one is x plus 6 squared. I don't know. Like I said, I don't use this that much, so let me see if I can make it work. I have no idea.
Do I put that in here as parentheses?
Let's see. Usually they tell you how they want it. So it says type, use a comma to separate them. I don't know if order matters, but we'll find out. It does not matter. Okay, there are 3 zeros. The multiplicity of the largest 0 is 1, right?
And then this one is 2.
And that one is 2.
There's not another 2.
Yeah, there's two -6s because of the square, which I find that odd.
So would that mean the multiplicity of variables of two?
Look at the example again. I'm not sure. Because I'm thinking it's just, what does it say here? The zeros of the polynomial for each 0 are 2 with multiplicity 1. And then -7 multiplicity 2. I think it might be 2 zeros instead of 3. I think that's the one you gotta select. The one that says there are 2 zeros. I think. But see, the square is tricking me because the square is twice. But it doesn't mean that it's, I don't know. Let's see. Let's try. Yeah, the square was throwing me off. Okay. So the graph crosses, I would use Desmos to be sure. Times x plus 7. No, it was x minus 7. And then times x plus 6 squared. And then just check that to make sure that's right. Is that the 6? That's the 6. So it touches at the -6 and it crosses at 7. Adding, sometimes it's the update. Who knows? It used to not work with the iPad. So which way did it come from on the left? Or which way does it go on the left side? Does it go up or down? On the left side of the graph. Remember the graph? Okay, go ahead. Uh-huh. Okay. So does it rise to the left or does it fall to the left? It's the only time you read in the center. This email rises to the left, falls to the right. That looks right. Are you trying to copy it? The copy function sucks. For both Desmos and for Pearson, it's going to do something. It's going to type something goofy in there.
Recording in progress.
Nope. It does not pop up as I can write on it. Let's see what happens if I log in. All right, I'm about to spy on the people who should be doing their homework too. So if you have not started, you're in trouble. You're going to get fussed at. You're going to call you out.
Okay.
Oh, you have an extra X in there. A lot. You just need to, it's cubed. You have cubed next to the X. That's a 6-degree polynomial. Whatever.
Oh, it doesn't fall.
So it rises left, it looks, and it falls to the right.
Yeah, we did.
Let me see that function again. Okay. So that's a 6-degree polynomial. That's 6. Wait, when it's 6, it's never mind. I don't know why it looks like that. Anyway, so it rises to the left and falls to the right. That's what it looks like. Is that all you had to do?
That was wrong.
Oh, what was the right answer?
Falls to the left, falls to the right.
Go back to the graph. All of them for x. The graph crosses the x-axis at I think it was ugh, the 0 is messing with me. I think it was 0, -5 because they're both. I can't remember. Maybe it was 3. Yeah, look at the example. I can never remember the touch one, the one it touches and turns. Uh, okay. Okay. So we have one at 0 and one at 4 and one at -3. Okay, the multiplicity of -3 is 1. So what does it do? What the heck was that? See, it's sorry, yeah, it's a 6-degree polynomial, so they both fall left and right. Okay, so I got that. All right, scroll back down. All right, so the multiplicity of -3 is 1, so the graph crosses. Okay, that's what I said. Okay. And then the multiplicity of 0 is 3, so the graph crosses at x equals 0. So crosses at odd, touches at even. Can you remember that? Just remember what I said. I may not remember what I said. Because I'm going so fast. All right. Okay. So it crosses at 3 and 0 and 3. That's fine. 0 and 3. And it touches at, oh wait, am I getting that backwards again? The odd ones, they cross. Sorry, no, it's -5. It's -5. Because the odd ones, they cross. The even ones, they touch. Okay, go ahead. And then the graph touches at the even power. So that one would be 3. You know why I probably can't remember it too? Because I probably never wrote it down when I learned it. I have no idea. Let's see. Usually when you plug 0 in, so you get isn't that 0? It's 0. All of it's 0, isn't it? Yeah. Okay. All right, let's start. Okay, it is symmetric. I don't know where that symmetry is because that graph looked crazy. So click the example. It should be symmetric with the origin, but I don't think it is. So if you plug in -x, do you still get the same function out? So if f of -x equals the original function, then the function is even. If f of -x then makes it the opposite, that's how you read that. So you see where it says recall? recall that if you plug in a negative x and you get the same exact function out, then the function is even. And then what is the symmetry though when it's even? Okay, so what is the symmetry? What's the symmetry? Okay, so if it's the same function that you started with, it's symmetric with respect to the y-axis. If it turns out that it's the opposite function, then it's symmetric with respect to the origin. And then if it is a hot mess, meaning it's neither, then it's neither symmetric. It's not, there's no symmetry. So do you know what I mean when I say plug in the negative x? Okay. So what would you get with the first one? That would change it. The second one, I don't know because let's see, I would have to FOIL to figure that out. Well, what you could do is have the calculator help you. So tell me it's -3, right? Oh, why did it do answer? Don't do that. Okay. And then that would be cubed, and then it was, what is it, x? What's next? X minus something? It was -3, right? And then that would be squared, but I need to change this to -x. And then the last one was -x plus 5?
Yeah.
Okay. So I don't know what it's going to do. So is that the original? Yeah. Okay, I think it's exactly the same, right? So if it doesn't change it, that means it's symmetric with. It's okay. It just put x minus 5 first. It's okay. So then that means that it's symmetric about the y-axis, I think it was, if it's still the same. The y-axis. I think it's y-axis if it's still the same. Wrong. Oh man. Which one was it? Neither. Okay. All right. It looked like the same function though. All right. And then the graph is probably B. It looks like that crazy B graph. Oh my God. Maybe it's D. Try D. F of 40. So, let me make this bigger. So, I think you have to, do you have to look at the graph? I don't know. Open the graph. I think there's a function on there. Maybe not. Okay, what is f of 40 approximately equal to? Oh, I think this is the estimate one. All right, what does 40 correspond to? What is 1970? Is that 2010? Yeah. So click done. Find and interpret f of 40. The polynomial estimate. Yeah, but did you see a polynomial? Error were at least 100,000. Do you see a polynomial on there? No, I think it's 161,100 because I don't see a polynomial. Oh, click the down arrow. It's the year first. So 2010. And then the polynomial S, but that's in the question too. Go ahead, click the example because I don't know. where you would. Where did that come from? There has to be a function for you to plug 40 into. That's what I was looking for. I'm like, well, where's the function at? Where do you see it? Oh my God. That's what I was looking for. I was like, well, where's the function for you? Okay, so plug 40 into that. You got the calculator right there. Just plug it in. What? What's wrong with your fingers? I know we're going fast, but I don't have a choice. So, yeah. So please, 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 if you are in any way confused about anything we are doing, read and do the examples from your textbook. I will try to post for my students that are doing IXLs. Bless you. Where's Brianna at? Okay. I was just looking at your score so far. All right. So you got that? Okay. And then so that would be the 40, wouldn't that be 40 comma 116,072? Wouldn't it? I'm thinking. Coordinate on the graph, that would be, I thought it was 40. Yeah. Okay. Just making sure. Unless you want to check the example to make sure that's what it is. Yeah. And then, because this is college class, ma'am. Okay, so now all you have to do is, does it overestimate or underestimate the actual data shown by the bar graph? I think it overestimates, doesn't it? Because it's bigger than 16,100. Okay. 50-50 chance you get it right. Oh wait. But or no, it underestimates. See, that's what happens when I don't have no food. I need to eat something. So you just subtracted two numbers. So 16,100 minus 16,072. I really don't have any food. Oh, you know what? Oh, I forgot, y'all. I do have food. I'm only giving it to people that started their homework. What food do you have? Yeah. Oh, Brianna. No, she's out 50 doing my homework for her. But there's like 5 parts to the same dog. She loves every second of it. What is that? Oh, out. You have something to drink? No. Are you going to show school? I need a water. I want 40 grams, but you're in charge of handing them out. If anybody wants some, Brianna's in charge. If you want some, all right, I won't make you in charge because they don't even want to come up to you. We'll let Ty be in charge since he's Jason. Aren't you Jason? Oh my God! I'm so glad I remembered this. I'm so hungry. Okay.
Will it fall to the right or to the left?
Well, hold on. What is the polynomial again? Is it a cube? You know what? You know what? Get it from the example. It should be the same exact one as the example.
Rise to the right. Because rise to the right.
What does it do? When the leading coefficient is positive, okay, whatever.
Don't continue.
Read that before never mind. What happens? Okay. Okay. When the leading coefficient is positive, the graph will rise to the right. But it will agree even or odd. When the leading coefficient is positive, okay. And the graph will rise to the right because the leading coefficient of polynomial exactly, which is positive. To determine the usefulness, interpret what the end behavior indicates. The population and compare hello with the mean what it means for the conservation efforts to fail. The polynomial is only useful if these. Okay, I don't even understand that. Determine the. So what actually is the? Did it say what it is? Is there anything underneath the graphs? No. Because I'm trying to figure out what is it actually. Because it's telling you to interpret the behavior, but it's like telling you the reasoning, but I'm not seeing. Oh, there it is. The graph will rise to the right because the leading coefficient of the polynomial approximately equals 0.63. So it rises to the right. Okay, go back to your answers. They all say that they rise. Okay, so it's probably A. It must be, yeah, it must be A. Okay, this is something that I have to teach you before we get into this. So we have to stop because there's no way I'm gonna be able to get that in. But I still will tell you, you should read your book. Those of you that are doing the IXL, I will give you long division in your IXL. So your book would be the learn from the example and the video. So for the rest of the time, Brianna, what section is it?